Welcome to this episode of Robert's Creative Chronicles. So today we are going to solve this question, which states that write down the mesh current equations for the circuit shown in the figure below and determine the currents I1 and I2. So first we have to identify the meshes. These are the meshes, this one and this one. These are the two meshes. So we have to apply KVL and Ohm's law to this mesh, and we have to apply KVL and Ohm's law to this mesh also. So let's do this. Now let's apply KVL to this first mesh. Now when we are moving in clockwise direction, so you can assume this thing also in anti-clockwise direction. You assume here anti-clockwise like this, you assume here anti-clockwise like this, both of them, but we are assuming clockwise. So when we move in clockwise manner from negative to positive, this voltage now takes the positive value. It will be 10, positive 10, because there's a rise in voltage from negative to positive. It's like it has moved from negative value of voltage to a positive value. If you are moving in anti-clockwise manner, it will move from positive to negative, so your voltage here will be negative. But since we are moving like this, it's positive now. Then here, current through this resistor will be moving from higher to lower potential. Now therefore, our assumed direction of current will be taken as the direction of the current flowing through this resistor. So we assume that the current flowing through this resistor and our assumed direction is flowing in the same direction. And current moves from higher to lower potential, so we'll be moving from higher to lower potential. Therefore, this will be negative. Now, when we move through this resistor now, this 5 ohm resistor, the reason for this negative sign is because we are going to there's the current we assumed is moving from here going through this resistor, and we're also moving in the same direction as this current, and current flows from higher to lower potential. So since we are moving in the same direction as this current flowing through this resistor, that means we are following the current to move from higher to lower potential. That means there will be a negative sign here, because we are moving also in the same direction as the current through this resistor, which moves from higher to lower potential, which is from higher potential is positive to negative. It's not because of this sign here. All currents through resistors or through circuits that is passing moves from higher to lower potential. So since we are following this current, we are moving from higher to lower potential. So the voltage here will be negative. So here will be negative 5, which is the resistance, then I1, which is the current. Now then 2 here, it will also be negative, because since we are following this current through this resistor, current is always moving from higher to lower potential, so it's now negative also. So negative 2, then since 2 currents are meeting, one is flowing from here downward and another one is moving upward. So this I1 and I2 are moving against each other. The equivalent current is now the difference between the two, which is I1 minus I2 equal to 0. So this is the KVL. We can reduce this to become 10 minus 5I1 minus 2I1 plus 2I2 equals to 0. Then this and this, 10 minus 7I1 plus 2I2 equals to 0. Now we can take this to the other side, become minus 7I1 plus 2I2 equals minus 10. So this is our first equation, equation 1. That means this is our first mesh current equation. Then to get the second one, we apply KVL to this. So when we are coming like this, so we are entering this first, so this one will be 2, but it's negative because we are moving in the same direction as this current through this resistor, and we know that current moves from higher to lower potential, so we'll be going to a lower potential from higher potential. So it's like a person that is moving from Nigeria to America. Your current location now is America. If you write your present residence, it will be America. So that is in the same way we are moving from higher to lower potential. The lower potential is America, which is why we are using that as the identity of these voltages. In the same way, when we are moving from negative to positive, you'll find what you are moving to is what you are going to take as your identity. So in the same way, that is what we are going to take as the identity of the voltage here. So let's apply KVL to the second one. Here will become negative 2 I2 minus I1. Since this is coming, this will come like this, and this will be going. So they'll I1 and I2 be coming against each other. So since we are working with I2, I2 be first, then minus this. This is the equivalent current. Then here is what? Minus 10 I2. Then here, we are moving from positive to negative. So our current one is negative 50 equals to 0. So now here becomes negative 2 I2 plus 2 I1 minus 10 I2 minus 50 equals to 0. So then we correct like terms. So this is negative and negative, so it's negative 12 I2 and this, then plus 2 I1 minus 50 equals to 0. So we can put I1 first to become 2 I1 minus 12 I2 equals to 50. We can decide to divide all 2 by 2 here to reduce this equation. So let me see, let's divide all 2 by 2, it become I1 minus 6 I2 equals to 25. So this is our second equation, second mesh current equation. So these are the two equations. Now it's time, so we can solve these two simultaneous equations by substitution method, elimination method, Cramer's rule, anyone. And you can always test it with your calculator to get the answer. So which method should we use? We can use Cramer's rule. So by Cramer's rule, using Cramer's rule now. So we'll find the matrix of coefficients. The matrix of coefficients given by this formula AX equals to B. A is the matrix of coefficients, B is a column matrix containing these numbers, negative 10 and 25. Then X is our variable, which in this case is current I. So this becomes this negative 7 and 1, then 2, which is this, and what, and negative 6. Then our current is I1, I2, then this is what, negative 10 and 25. So by Cramer's rule uses determinants. So in this one, A is equal to minus 7, 2, 1, and minus 6. So we'll find the determinant of this. Also, A1 becomes, you replace the first column with this to get A1. Then 2 and minus 6. Then A2 You replace the second column to get A2. So now we find determinant. So the determinant of A, let's use a calculator. So let's save all these matrices before we find the determinant. Matrix mode. Mat1 will be this, mat2 will be this, and mat3 will be this. So it's a 2 by 2 matrix. Then it's -7. Then we press shift. This, we press shift and we press matrix. So I just press shift and matrix. Then you press 2. Press this data 2. Then you press 2 again for mat B. Then you select 5. Put the second matrix -10, 25. -10, 2, 25, and -6. So you press shift. Then this 4. Then you press 2. Then you press 3 to represent mat C. Then 5. So it actually depends on the matrix. There is 3 by 3 and it is -7, -10, 1, and 25. Then you press this AC to save it. So it's now saved. Now we can find determinant. Now you press shift and 4. That is for matrix. You see matrix on the 4. So we press determinant, which is 7. Then we press again shift and 4. Then we press mat A, which is 3. Then we close the bracket. So the determinant of this first one is 40. Then determinant of the second one, shift matrix 7, shift matrix mat B 4. Then it's 10. Then the last one, the determinant is 7, then 5. No, this one is -165. So it's -165. So this is the 3 determinant. Now let's move to the next step. Now here are the various determinants. It will be this divided by this, which is equal to 10/40, 10 divided by 40, 10 divided by 40 is 0.25 ampere. So this is the first current. That means this one, the assumed direction clockwise, is actually the same as the actual direction of the current in the mesh. That means this current I1 is actually moving in clockwise direction, this mesh. And the second one, I2, negative 165 over 40. Is negative 4.125 ampere. That means this one is moving in the opposite direction. The assumed direction is not the same as the actual direction. This one is moving like this in anti-clockwise direction in this mesh. And it's even reasonable. You know, current flows from positive terminal, from positive terminal voltage. So this, there will be current moving from like this from this positive terminal. Then to split here. Some of it to come back to this. Then the current also will move from here to split here. Some of it to come back here. So actually, this is actually very correct. So this is moving in clockwise, this is moving in anti-clockwise. So this current I1 is moving in clockwise direction, and this is moving in anti-clockwise direction. So this is correct. Now I'll quickly be showing you a short way to test whether your answer is correct. Now, according to KVL, the sum of the total voltage in this mesh should be equal to 0. The algebraic sum of all the voltages, and likewise this one. So you can easily test. Bring your calculator and say 10. That means let's move like this. So it will be 10 plus what? The current I1 is 0.25. We have I1 now. So it will be plus. But okay, since we are moving in the same direction from higher to lower potential, it will be negative. Negative 0.25 times 5. Then negative 2. Then it will be I1, which is 0.25 minus I2. I2 is what? So it will be minus. Then this is minus 4.125. So this should give us 0. Show the answer is correct. So you see 0. That means what we did is actually correct. So even this mesh, we do the same thing here. It should also give us 0. So this is all about mesh analysis in this example. So successfully we have found the mesh current equations for the circuit shown in the figure, and we have also found the currents I1 and I2. So I hope you understood this episode. If you have any question, feel free to contact me using my WhatsApp or email it in the description below, or you can write them in the comment section. Thank you for watching. Please don't forget to like, share and subscribe to my channel, and hit the notification bell to get notified as soon as I drop a new video. Thanks.